in the moment of the 30-pound force about the point O. So we had this figure. Now we want to draw a free body diagram. I used the BREAD acronym to make sure I did everything. So here I have my body, which I made, well, it's pretty much the same as before, but usually you want to make it a little bit simpler, but in this case it's already pretty simple. Here I'm just going to put this angle right here, and I want to do it in blue, and this angle right here, they're telling us that is 50. Let me make that 5 a little bit better, 50 degrees. I already put, so the dimensions are going to be these two angles and the 3 feet. So the dimensions are good. So I can say dimensions are good. The axis, we're going to say that our axis system is this. So this is our X. This is our y-axis system. Now the externals. So I didn't put the external forces yet, but there's got to be a force, perhaps a force at O in the y direction, and I'll draw it up. And a force OX, just like that, right? And that's the only contact we have, and we're making some assumption. We're assuming the member is static. And why am I saying that? Well, because if the member is static, then there's got to be a force that counteracts the 30 pounds, both in momentum and in translation. And so we did the dimensions, we did the axis, we did the externals, and the reactions are a part of the externals, I think, and we have the body. So now that we have this, there's another thing that we must do. So remember to use SS stress. So strategy system. So then I'll use this other acronym to make sure that I'm hitting everything. So SS stress, and I'll tell you what it means. So strategy, system, and then we have the draw, the resolve, and then the equations, then we have the solve and the sanity. Solve and the sanity. Check. Right? So the strategy. What is my strategy going to be? So my strategy is going to be Newton's second law, both for moments and the forces, because they're going to be equal to 0. Now the system, see above, it's what we drew over here, right? This is our system. So we've got these two parts right here. Now what else? Draw, that's the drawing once we figured out the system. And now we want to resolve the components. So we want to resolve, what does it mean to resolve? Well, we want to break the 30 into the parallel component to the x and the parallel component to the y. So why don't we do that? And let me just save this real quick, because sometimes it'll erase all my work, and I don't like that. So we can resolve this force. Let's see, what's the best way to resolve it? I think if we put, let me see, it's downloading it again. And this is where I get very scared, because sometimes it crashes. And see, okay. Well, while it's doing that, I was thinking perhaps I want a different a different y and x, because if I line my y and x with this beam, look what happens. So if I align my y and x, so say this is my y and this is my x. So this is my x and this is my y. Then I'm going to have to change these. So bear with me for a second. I'm going to have to change these, and there's going to be one this way, OX, and an OY, right? So now I can resolve this component by just doing this. And so let's see, how could we do that? Well, let me get our black pen. Resolve. So we'll do the resolve portion here. Resolve actually is complete equations. So the equations that we're going to use are the sum of the forces in the x direction is equal to 0 because we're assuming the member is in equilibrium. Same for the y. And then the sum of the moments about the point O are also 0. And so now we're going to solve it, because we have everything. And so we're going to solve it. So let's see, all of the forces, oh, and I didn't resolve. That sucks. So resolve, I'm going to have to rewrite this. So I'll put resolve here, resolve, and it's going to be the force at A. So we'll call this FA. And so we'll say that there are two forces, and the two forces are FAX and FAY. So we'll call them FAX. FAX is going to be equal to what? FA times the cosine of 30 degrees. And FAY is going to be FA times the sine of 30 degrees. Now, if you remember our triangle and unit circle, if this is a 30, this is a 60, the sine is going to be a half, and so this is going to be 1/2, and the cosine of 30 is going to be square root of 3/2. So now we can write that FA is going to be 30 pounds times the square root of 3/2, and this one's going to be 30 pounds divided by 2. So this is 15 pounds, and this one right here, let me get my calculator out. It's going to be 30 times the square root of 3, all of it, divided by 2. So I could have done, and so that's 15 square root of 3, or about, I'll leave it as 15 square root of 3. And remember that it's pounds. Okay, so once we have resolved, we can say equations. So I'm just rewriting what I did earlier. Sum of the forces in the x is going to be 0. Sum of the forces in the y is going to be 0. And sum of the moments about c is going to be 0. And now we're going to do the solve part, right? So the solve part is we're just going to add the forces in the x and the y direction. So in the x is going to be OX, which is going to be in the negative x direction. So we're going to say negative OX plus AX, which FAX x is going to be equal to 0, which is OX is equal to FAX, which is equal to 15 square root of 3 pounds. Okay? And now that we have the first one, we can look at the, I don't think we even need to use all of these. We'll do all of them because I started with all of them, but then I'll erase what we don't need. So OY is going to be positive. OY minus FAY equals 0, and that's going to be, okay, I need more space. So OY minus FAY. OY minus FAY is equal to 0. So OY is equal to FAY, which is equal to, well, FAY, we have it right here, is 15 pounds. So now we have those two. And now the sum of the moments, this is the drum roll moment. No pun intended. So we have a force that's going to create a moment, and I forgot to put the moment here. So there's going to be a moment right here, and I'll put it in red. And so we're going to say that the moment at C is equal to 0, and what is that? So OY and OX act at C, and I think we wanted the moment at point O, not at C, so I don't know why I put C. We want the moment at point O, so even here we want the moment at point O. And so really all we had to do, but this was a good review, is we just had to say that an FAX also acts on the line that passes through O. So the only thing that creates a moment is FAY. And if you use the right-hand rule, you'll notice that it's into the page, the vector of the moment, so it's going to be negative. So we'll say that negative 30 pounds, that's the force, times the distance at which it is applied, which is the distance from O to A, which is 3 feet, that's going to be equal to, and then, no, we're not done, plus the moments at O that don't make this move is equal to 0. So if you bring that, we do negative 30 times 3, that's negative 90. We bring it to the other side, so M at O is equal to 90 pounds per feet. So really, this was what we had to do, and everything else is extra. So these things are extra. I'll just keep them for now, and then we'll ask the instructor if they want us to keep it. This is extra. But had they asked you, well, now find the forces and that happen at O, then this would have been the way to do it. Well, so now we did solve. And now let's think of a sanity check. So for a sanity check, what can we do? Well, we're saying there is a positive moment of 90 pounds per feet, pounds times feet, pound feet. And it's in the other direction. The moment MO is opposite to the moment produced by FA at O. So that's a good sanity check, I think. I hope this was useful, and I'll see you next time.